We're going to have a lot of fun in this nugget, learning how to work with virtual machines in failover clustering. We'll begin by spinning up a cluster of Hyper-V hosts. Then we'll look at some common management tasks around them, some of which you've seen before, such as live migration. We'll look at them again and how they pertain here to failover clustering. And then we'll also look at a bunch of great features, such as node fairness, network health protection, VM monitoring, and drain on shutdown. And we'll learn how to work with those and configure them. And at the end here, we will spin up a guest cluster. That's a cluster out of virtual machines that are running on our cluster of Hyper-V hosts. So this nugget is basically one giant cluster. Let's fire up the virtual lab and get started. Once again, I've logged into our Windows 10 administration box here, Admin Nug. We'll be performing all of this stuff remotely from this machine. Let's begin by getting into our tools. The first one we're going to get into here is the Failover Cluster Manager. So let's run a clueadmin.msc. So we have our CL-NUG cluster ready to go here. Again, this is a 2-node cluster formed by CL1 and CL2 NUG. We also have a disk witness set up as a nice SCSI target over there on FS-NUG, our file server, and that is also the shared storage for this cluster. Now, I did give us a little head start here. If we click on roles, you're going to notice we already have a couple of VMs running. And I did this because a lot of the stuff here to get to this point we've already done in previous nuggets, but I still want to walk you through what I did to get to this point. The first thing I did was transform these 2 nodes into Hyper-V hosts. And to do that, I opened up PowerShell and I ran an invoke command against CL1 and CL2 NUG and installed the Hyper-V role, just like so. That's what I did. That installed the Hyper-V role on both of those machines. The next thing I did was configure the virtual machine cluster role onto this. So I right-clicked on roles, chose configure role, which took us through the high availability wizard here. And at the next screen, I chose virtual machine. Now, what this did, and all of this did, was enable live migration over on those Hyper-V hosts. In fact, I'm going to right-click on the Start menu again, head up to Run, and let's type in virtmgmt.msc. This will launch us into Hyper-V Manager. So if we head over here to our Hyper-V settings, and down here to live migrations, you'll notice that it's enabled, and it also configured the 3 subnets for incoming live migrations. So that's all enabling the virtual machine cluster role over there in a failover cluster will do. It'll enable live migrations on both your hosts and set up the networks. Another thing I did manually here was configure an external switch on both of these hosts and bound it to the network adapter containing the one network. That way our virtual machines can get outside and onto the physical network and join the domain, which we'll need to do when we set up guest clustering. So that's about all I did on these hosts manually, was set up this external switch. Now, the next thing I did as we head back into the Failover Cluster Manager is set up storage, shared storage. So if we head down here to storage and disks, I took that available disk and added a cluster shared volume on top of it. So we have a CSV here, and this provides us with a shared location for storing those VHDs. And we're not on top of a failover cluster. This is just simply a CSV sitting on top of that iSCSI target over there on FS-NUG. And finally, I created those virtual machines. And I actually did this right here in the Failover Cluster Manager. It gives us a nice centralized location where all we need to do is choose what host we want to create that VM on. So I right-clicked on roles, chose virtual machines, and chose new virtual machine. Choose which host you want it to initially live on, and hit OK. And then it'll walk us through a very familiar wizard, the new VM wizard here. I chose next here, gave it a name, and feel free to do this. If you want to walk through this process and create VM3 NUG, absolutely, go to it. So I gave it a name, and here's the important part here. I checked this box and chose our volume, our CSV here, for cluster storage. So on CL1 NUG, I went right into the C drive, cluster storage, volume 1, and look at that. There's VM1 NUG and VM2 NUG. So I selected this folder. It'll automatically create a VM3 NUG folder inside of that CSV. I hit next. I chose my generation, hit next again, chose the memory here, hit next again, configured networking here and pointed at our external switch, hit next, and specified the virtual disk. This is going to be the boot disk, by the way. I just took the storage down here to about 30 gigs. Notice here it's also going to plant that in the virtual hard disk directory in that VM3 NUG. I hit next, and then I chose to install an operating system. And notice here that I have an ISO's SMB share over on FS-NUG. And so there is inside of there the Windows Server 2016 installation media. So I pointed it to that and hit next, and then finish. And that created the VM, and then I logged into that VM, installed the operating system, gave it an IP, joined the domain, and that's where we are. Oh, and by the way, I did need to do one more thing, and that is set up constrained delegation. That way we could hit that ISO living over there on FS-NUG. In fact, just to show you that here, let's bring up dsa.msc, Active Directory users and computers. And let me show you how I configured this. So on FSNUG, if we go into the properties here and go down to delegation, notice here that I set up CIFS for both CL2 and CL1 NUG. And then I did the same thing here on CL1 NUG and CL2 NUG. By going over to delegation, I set up CIFS, both of those, constrained delegation for any protocol, over to FSNUG. And then I bounced both of those machines. And by the way, you don't need to fully reboot those machines. You can actually just bounce the Hyper-V virtual machine management service, which is what I did on both of those machines. And there we go. Now, those virtual machines were created. We'll be able to do live migration, and all of that stuff is configured appropriately. So we are officially ready to rock. We have VM1 NUG over on CL1 NUG and VM2 NUG over on CL2 NUG. And we can also see that here inside of the failover cluster manager. We can see what the current owner node is. That's the host that's currently running that VM. Let's start by performing some migrations. Very easy to do here in failover cluster manager. If we right click on either of these VMs, notice again, VM1 NUG is currently hosted on CL1 NUG. Let's say we wanted to migrate this VM1 NUG over to CL2 NUG. Notice here we have quite a few options when we right click on a VM. We can do a lot of the same stuff we can do over in Hyper-V Manager. We can get a virtual machine connection window up. We can hit settings, which will take us right directly into the same settings page we see over there on that VM in Hyper-V Manager. We can even right click on it here. We can shut it down. We can turn it off. We can replicate if we have Hyper-V Replica enabled here. But under Move is where we can perform a live migration, a quick migration, or a storage migration. Now, live migration works just like it does over in Hyper-V. Quick migration is not available over in Hyper-V Manager. This was the old way of doing it. This is what live migration eventually became. And the difference between these two is that a quick migration will actually pause the VM before migrating it over. So there will be an interruption in service on that VM during the migration. But the upside here is you can migrate while the machine is off. So live migration only when the machine is on, quick migration when the machine is off or on, but you will get a service interruption. And generally, you only perform a quick migration when you can't perform a live migration. Let's do a live migration here. Let's choose best possible node. This will switch it over to CL2 NUG, and you'll see how quick and easy this is, and that our service will not get interrupted. In fact, I should have logged into that machine, opened up Server Manager, done something, and kept our virtual machine connection window open. You'll see that it wouldn't have closed. But if we did a quick migration, it would have closed and disconnected our session. We would have needed to reconnect to it. But look at that, we're now on CL2 NUG, and if we head back to Hyper-V Manager, you'll notice here on CL2 NUG, both VM1 NUG and VM2 NUG. Nice and easy, right? And now nothing is running over on CL1 NUG. Now let's perform a quick migration for VM2 NUG. Before we do this here, let's get a connection up, as this way you can actually see that we will get a service interruption here and we will lose this connection. All right, so that is connected. I'm just going to go ahead and minimize this. And now let's right click on VM2 NUG, head down to Move. Let's do a quick migration here to the best possible nodes, which will switch it over to CL1 NUG. And you'll actually see that it's going to save the state of this VM. So it's essentially pausing it. And then there goes our virtual machine connection. Yeah, we know, no. We're going to get an interruption in service. And now it's going to perform the migration, and then it'll fire it back up. And now we're on CL1 NUG, and we would have to reconnect. So that's the difference there between a live migration and a quick migration. Now we can also perform a storage migration here in Failover Cluster Manager. You may want to do this if you're moving storage to a different shared storage location, or maybe you just want to migrate it off of failover clustering for whatever reason and onto local storage. What you can do here is the same thing. Right click on your VM, head down to Move, and this time choose Virtual Machine Storage. And the interface here is a little wonky compared to the storage migration wizard over there in Hyper-V Manager, but it essentially works the same way. What you do here is you pick whichever items you want to migrate. So we have the same choices here as we did over in Hyper-V Manager. We can migrate our VHDs, we can migrate checkpoints, smart paging, and configurations. But what you essentially do here is choose which one you want, hit the copy button, and then down here you choose your second location. So if we had a share down here, I actually have an ISO share. I'm just going to add that share into here. We'll do fsnug ISOs, and that'll add that into here. Now we can choose this and hit paste. And what that'll do is paste this in to whichever location you have selected over here. See this? So up here it'll show us your source and your destination. You can do this for whichever items you want to migrate. You hit start and it'll send them over, and then it'll also update those locations for these VMs inside of the VM settings. All right, so same concept as we did back in our Hyper-V section, just migrating storage from one location to another. I'm going to cancel out of this because we don't need to do that. Now, another thing I want to give a quick mention to is importing, exporting, and copying VMs. This is kind of a duplicate objective here because this isn't something that we do in Failover Cluster Manager, and it works the same way whether your VMs are clustered or not. But if you do right-click on a VM, and you can head down here to the Manage button, this will actually launch us right in to Hyper-V Manager and highlight this VM on that Hyper-V host. See that? And from here, you can export just as we did before. And again, this all works the same. We looked at exporting, importing, and copying VMs around back in our Hyper-V section, as well as the PowerShell commandlets that you can use to do the same. So just wanted to point that out, that you will not be doing any importing, exporting, or copying in Failover Cluster Manager. That is something you will still do here in Hyper-V, but it works the same. And failover clustering does not have any effect on that process. Now, moving on, let's talk about some of these great virtual machine features built into failover clustering, starting with node fairness. This is a really cool rebalancing feature built right in here to failover clustering. And to access it through the GUI here, we can right-click on our cluster and head down to Properties. You're going to notice we have this Balancer tab here. Now, this is something that only applies if you have virtual machines here in your cluster, or Hyper-V hosts in your cluster, and you have that virtual machine cluster role installed. This isn't something that you can configure over in Hyper-V Manager, and it is enabled, as you can see, automatically. What this will do is, depending on your settings here, live migrate our machines off of overutilized host onto underutilized host to keep the balance across all of our cluster Hyper-V hosts and the VMs on them. Now, our first setting here is the mode. This is going to determine how often this rebalancing process runs in the background. The default is to always load balance, which is 30 minutes, or whenever a node joins or rejoins a cluster, it's going to evaluate the CPU and the memory on all of our Hyper-V hosts. And if they're overutilized based on this aggressiveness setting, high is 80% of CPU and memory, medium is 70%, and low is 60%. So if we've gone over this threshold for our aggressiveness setting here, it will live migrate a node to another Hyper-V host to attempt to balance it out. So a really great feature, and if you ever wanted to disable it, here's where you would do that. You could also tap into the properties of our cluster. There's an auto balancer mode as well as an auto balancer level to configure all of these settings. All right, moving on, let's talk about VM network health protection. This is another simple, cool little feature that can potentially increase the availability of our VMs in case the network they're connected to goes down. Now, this is something that we configure at the NIC level per VM. So I'm going to give VM2NUG a right click here and head down to Settings. We only have one virtual NIC in this machine, and it's currently connected to our external virtual switch, which is connected to the one network, bound to that one network card in our Hyper-V host. But if we expand this and head down here to Advanced Features, here is that checkbox, Protected Network. Notice that it is enabled by default. So what we're saying here is if this VM ever loses its connectivity to that virtual switch, or I should say that virtual switch loses its connectivity to the network card that it's bound to, in our case the one network, what the cluster will do is evaluate all the other nodes. And if that network is down for all the other nodes, then it's going to leave this VM where it is. But if that network is available on other nodes, then it will live migrate this to another node in the cluster, another Hyper-V host in the cluster where that network is available. So this is about all you can do, is either leave it on or turn it off. I can't really see any reason for turning this off because obviously that reduces high availability, and that's what failover clustering is all about. Moving on, let's talk about another cool little feature called VM monitoring. If we scroll down in our summary tab here, notice we have monitored services and there are none. Now, what this feature allows us to do is essentially allow our cluster to restart one of these VMs if a service becomes unresponsive multiple times. Now, this will be useful for things like IIS and SQL Server and machines that have a single workload, because you may want Failover Cluster Manager to reboot that machine if its primary workload stops running. But again, if you have a multi-purpose machine with many workloads on it, then you may not want to do this. But it's very simple to configure. We right-click on the VM itself. We head down here to More Actions, and we choose Configure Monitoring. This is going to query all the services inside of that VM. So here's where we would pick and choose which services we wanted to monitor. I'm going to pick the print spooler, for instance, here, and hit OK. And now we'll see that down here in our list of monitored services. Now, how this works is, first, if this service fails, then the Service Control Manager on that VM will attempt to restart it. Let me show you those settings here. I'm going to right-click on Start, head up to Run, type in services.msc. You're going to learn a lot of shortcuts throughout this course of launching these tools. But here we are. We need to connect to that machine now. So I'm going to right-click, connect to another computer. Let's connect over to VM2NUG. We also could have just logged into VM2NUG and did the same thing. But hey, this is what remote management is truly all about, right? Doing everything from one machine. So now we are connected to VM2NUG here. And if we scroll down, let's find that print spooler service. There it is. If we open this up and head over here to recovery, this is the default here. Restart the service and then restart the service. So first failure, service control manager on that machine is going to try to restart it. Fails again, going to try to restart it. At the point that it hits take no action is when the cluster is going to take over any of those monitored services and just reboot the entire machine. So that's what this feature is all about. Again, a very simple feature here, but very powerful, especially, again, if you have single workload VMs and you want them to reboot if something goes wrong with their primary service. Moving on, let's talk about one more cool little feature here called Drain on Shutdown. Now, Microsoft implemented this back in Server 2012 R2, probably to cut down on the number of support tickets they were getting from Hyper-V administrators, but also to save us from ourselves, because let's face it, every now and then we forget a step in the process. Now, here's how we were supposed to do this prior to this feature. Anytime we wanted to take a Hyper-V host, a node here, down for maintenance or down to patch or down to do whatever we needed to do, we were supposed to drain the roles. So right-click on the node, hit pause, drain roles. Again, that will live migrate those cluster roles to another available node in the cluster. If we forgot to do this, then it would cause all kinds of problems. If we just shut down our Hyper-V host without performing this step, well, those roles are stuck on that machine, which is now down, which means our workloads could potentially as well be down. It would cause all kinds of problems with our cluster and our workloads. So this drain on shutdown feature is enabled. It's on by default. I don't see any reason to turn it off, and it will essentially do this for us anytime we shut down our Hyper-V host. So no more shutting down our Hyper-V host nodes and taking our virtual machines with it and the workloads on those virtual machines with it. Now it will automatically drain those roles and migrate those VMs over to another available host prior to shutting down. Let me show you how you can control this in PowerShell. I'm just going to launch PowerShell down here from the taskbar as an administrator. And we'll run a get cluster here, passing the name of CLNUG. We'll pipe that over to format list, asterisk to pull back all the properties of our cluster. The name of this property is drain on shutdown. You can see it is enabled by default with a 1. You can disable this if you want to by setting that value to 0. And by the way, also notice here's that auto balancer mode and auto balancer level that you can control for node fairness. All right, I'm going to minimize this, and let's move on to our last section here, which is creating a guest cluster. Now, there's a lot of advantages to creating a guest cluster, and that is creating a cluster out of our VMs. The obvious one is we can make the workloads on those VMs highly available. Another one is creating the cluster is easy because we don't have to worry about hardware compatibility issues. They're all VMs, they all have the same hardware. Plus, we can take advantage of all those sweet VM features that we were just looking at here in failover clustering. Now, there's just a couple of configurations we need to make before we can build a guest cluster out of both of our VMs running on our Hyper-V cluster. And that is, number one, we need to install the failover clustering feature on both of these VMs. No problem, right? And number two, we need to set up shared storage. And we're going to use a VHD set for that. Let's start by getting the failover clustering role installed on both of these VMs. So let's bring PowerShell back into the picture here, run an invoke command, targeting both VM1NUG and VM2NUG. The command we'll send over there is an install Windows feature, failover clustering, just like we've done before when we stood up our original CLNUG cluster. And that completed successfully and will not require a reboot. Next step here is to set up shared storage, and we can do that right here in Failover Cluster Manager by right-clicking on Roles, heading down to Virtual Machines, and choosing New Hard Disk. Choose one of those nodes in the cluster here and hit OK. This will launch us into the new VHD wizard. I'm going to go ahead and choose Next Step before we begin. Let's go ahead and create a VHD set here. Choose Next. We'll keep that dynamically expanding, and let's just call this one, how about VM Shared? And we're actually going to place this on our cluster shared volume. So we need to browse here over to CL1NUG and the C drive, cluster storage, and we'll just place it right there in that CSV and hit select folder and then next. Let's give this one, how about 100 gigs? It's dynamically expanding so you can make it as big as you want. Hit next and we're done. We've created a VHD set, something that we again have done in a previous nugget. Now all we need to do is hook that up to both of these VMs. So we can go into the settings of each one of these VMs. We'll start with VM2NUG here. Head up to SCSI controller. Let's add a new shared drive in here. And let's go ahead and browse. Once again here, we'll need to browse to our CSV here in the C drive, cluster storage, volume 1, and there is our VHDS. So we'll open that up, and this one is good to go. So we'll hit OK here, and let's do the same thing for VMNUG. We'll right-click, head into Settings, choose our SCSI controller, hit Shared Drive, hit Add, and now we'll just browse right over to that CSV here, in this case on CL2NUG here, as that's the same shared location. So volume 1, there it is, VHDS, hit Open, hit OK, and now we've got shared storage set up. The only thing we need to do now is log into one of these machines and bring that disk online, initialize it, and format it. So let's do that real quick as well here. I'll just choose VM1NUG. Right-click that, head to Connect. We'll set this up as a 1280 by 720 connection. Give that a second, hit the View menu here, and go full screen. Log in with our standard lab password. And we can just do this in Server Manager. You could also go in the Disk Management to do it as well. I'll hit File and Storage Services here. Go to Disks. And there it is. There's our unknown disk. So we're going to right-click this, bring it online. Go ahead and choose Yes here. And now we just need to initialize it and format it. So we'll right-click again. We'll initialize it. Nothing new here, right? This will turn it into a GPT disk. And then we'll right-click one more time and create a volume on it. Run through this wizard real quick here. Next, it'll be 99.9 gigs. We'll give it the drive letter. How about of S here for shared? There we go. Hit Next. Call this one, how about data? Hit Next, and we're done. And that's it. We are ready to create our guest cluster. Let's do it. Let's head up to Failover Cluster Manager, the very top node. Give that a right click and choose to create a cluster. This will also ask us if we want to validate the cluster, which we'll do because it'll be very quick since we're working with VMs. So I'm going to hit Next here, and we're going to add both of our machines in here. There's VM1NUG. We'll add that in and let it verify that it exists. It does. And then VM2NUG. And we'll do the same thing. Go ahead and choose Next. It's going to ask us, do we want to validate? Let's go ahead and choose Yes here. We will validate it. Hit Next, which will launch us into the validation wizard. And this should be pretty quick here. So we'll hit Next. We'll choose to run all the tests. Hit Next. Hit Next one more time. And again, this should happen very quickly. All right, so mine just finished. And I suppose it depends on your definition of quick. I'm getting old, so time moves fast. But yeah, that wasn't as quick as I made it sound. But it's done, and it completed successfully. Now we can hit Finish. And we're back to our original wizard here, where we can now give it a name. Let's call this one, this cluster, VMNUG. We'll specify an IP. I'm just going to go .140 and hit Next. We'll make sure that we're adding all available eligible storage into the cluster and hit Next. And it's going to create the cluster. And look at that. We've created ourselves a guest cluster. If we hit Finish, it should show up over here in Failover Cluster Manager, and now we can manage both our physical host Hyper-V cluster as well as our virtual machine guest cluster. And this is the recommended setup, by the way, is having your Hyper-V host in a cluster, that you're going to be obviously having your virtual machine guests in a cluster. That way you have redundancy at both levels, because if you only have one host, well, what's the point of making a guest cluster? If that host goes down, since it's a single point of failure, your cluster inside your guest cluster goes with it. Now, one more thing we should do down here is configure quorum, because we only have 2 nodes here. So let's right-click on that cluster, head down here to More Actions, and we will configure cluster quorum. And we're going to set this up as an SMB witness. So we'll go ahead and hit Next here before you begin. We'll choose to select a quorum witness here, hit Next. And let's configure a file share witness, hit Next. And I've got a file share over there on FSNUG. So we can actually just browse through it here and type in FS, hit Check Names. There it is. Okay. And there, I made a share called witness. Can I get a witness? We got one. We'll hit OK. Next, Next, and Finish. And look at that. We now have quorum configured, we have a witness configured, and we have 2 nodes inside of this guest cluster ready to go. At this point, we can start adding cluster roles to them and make those workloads highly available. See, wasn't that a good time? We covered quite a bit here in this nugget on implementing Hyper-V clusters. We learned how to spin up a cluster of Hyper-V hosts to make our Hyper-V hosts and the VMs on them highly available. We took a look at some common management tasks such as live migration, quick migration, the differences between them, and storage migration. We talked about a lot of the great built-in features in failover clustering for our VMs and our Hyper-V hosts. Node fairness, VM network health protection, VM monitoring, drain on shutdown, and we even saw how to implement guest clusters as well as their shared storage. I hope this has been informative for you, and I'd like to thank you for viewing.